interesting, like browser LAN party.
Yes, browser LAN party.
All right, I'll hand it over to you.
Okay, so I know I'm the last one, and you're probably all very tired, but so I'm going to try and keep it short and interesting, and we're going to start with something cool to get you all up. I'm just going to get the mirroring off. Okay. So, this one. And we can get started. Okay, so hi everyone, I'm Barak. I'm from London. I am a software developer for a company called Rocket Labs. And what I'm going to be talking to you about today is a browser LAN party. So who ever had a LAN party? Or, yeah, okay, yeah, cool. So a LAN party, for whoever doesn't know, is basically when you get in a room with a bunch of your friends and you play games over a local network, if it's like Call of Duty or Grand Theft Auto or whatever else you like to play. And it's a lot of fun. And everyone's in the room and you play together. And I wanted to do that in the browser. So I built a game. And the game's called Overboard. I built it a few months ago. And it wasn't initially a LAN party worthy game. Before I show you the next slide, because there's a link and we're all going to play. It was a basic web-based game, kind of like a Wii. You get the main screen being the console, sort of, and every phone is a controller. So we can try and get this to work now. We'll see if that's going to work over the local network. So my IP is on the screen. Hopefully it doesn't die. We'll see. Trying to get this to run. So if you're connected to your phones, don't go to your computers, go on your phones. Yeah, go on your phones and give me a second. Okay, so if you go to that IP, port 3000, it will ask you for a room. Go to CAMPJS, all lowercase. Yeah, I don't know if it'll just die immediately, but we can see. Just want you guys to see what. Oh, here we go. So we have people, and you control it with your phone. You can see we have people there already. And if you press the screen, you're going to shoot someone else. There's a circle around the player that's your health. Yeah, and does beep, beep, that's me in very high pitch. So there's, yeah, oh wow, a lot of people. Oh, so I'll just duck for a second.
Can you put the other side, please?
Well, let's see. Where is it? Yeah, 10, 13, 37, 200, 4, 3000. Wow, a lot of people. Yeah. Funny thing about this, like, I can build games, but I'm terrible at games, so I'm not playing for a reason. Whenever I present this game, the first one to die, it kind of sucks. So, anyway, okay, you guys had enough fun. We can play later. Stop shooting, the game is over.
Game's in forever, Barak.
Okay, back to the serious presentation. Okay, so, Overboard. Overboard is a mobile-controlled arcade game that I built, and it works over Socket.io. There are a few cool things about the game itself, but we're going to be focusing on networking. Just a few cool things about the game itself. So, yeah, it's like it works sort of as a Wiimote. Cool thing about it is we built it without a framework. We used ES6 and 7 as a framework. In the same way that Unity works, if you're familiar with it. So we built basic game objects, and we augment them with functionality, with decorators, like ES7 decorators, even though the spec for decorators, the current one is sort of deprecated, but it doesn't matter. So I don't know if you can see, but you basically have a normal game object, and you can attach a decorator to it that makes it a movable or a collidable or a bunch of different functionalities. And it's really easy to build different game components with a lot of functionality that's composable, and that was really cool. Beyond that, something about how the game rendering works. There's a worker doing all of the game state, and the networking and everything else. The only thing that happens in the main thread is rendering. That was done by design to make sure that the game can handle sort of distributed networking, where only one computer is the brain of the game, and we can share state across multiple machines. We'll get to that in the end. I'm just mentioning it now. And the rest of, really the way that it works is we communicate over WebSockets, and you can see that when you had a bunch of people connecting, it sort of got a bit laggy. It's not really the performance of the game itself, but sometimes when you have a lot of people connected, networking gets really sort of poor. And this is the idea behind this entire talk, and really why I wanted to build a game without a game server. So why do game servers suck? For a bunch of reasons. But the main thing that I noticed that makes sort of game servers suck for me is that often networking is a bottleneck when building games. Even if everyone is in the same room, it's a bottleneck. We depend on a server being up for a game to work, which is annoying. Again, even if everyone is in the same room, and like we're here, we're all in the same room and want to play a game, and there's no internet, so we can't play, sort of case in point. So how do we solve that? How do we create a game without a server, or without the need for a server for networking? And this is what I was after, a way of doing that just in JavaScript, just in the browser, and really without any server deployed for communication. So if you look at the way that sockets work, the only thing that they do is they relay messages. Given that there is no game state in the server, you send a message to the server, and the message is being relayed to all of the other connected sockets. Try to figure out, like, why do we need the server to relay these messages? There's really no point if that's the only thing that it does, and it has no other manipulation of game state or everything else. All the game state happens, all the game management happens on the console or in the computer. So the action plan really is to convert the game to work with WebRTC, because it's peer-to-peer, and it's going to be super fast and awesome. So let's talk about WebRTC. Who has worked with WebRTC before, or is familiar with WebRTC? Okay, so WebRTC is Web Real-Time Communication, and what that means is that computers, browsers, are now capable of opening a direct session between one another, facilitated by a server still, but the session itself is peer-to-peer, so we're able to communicate between browsers without the need for a server. So that's, someone is still shooting. I'm glad you're loving it. It means that two computers can communicate between themselves without the need for a server. And that means that the communication is faster, but also that there's no direct bottleneck in terms of the network having to go through the server. And there's less of a lag. So if you're closer to each other, the communication will actually be faster. So usually you will need a server to trade what's called a description, SDP. And that means that it's similar to having an email address or a phone number. You need to get the other person's phone number before you can call them. So I have a description of my session, which is sort of my location in the internet. And another computer has their description, which is their location in the internet. And when we share these descriptions between ourselves, we can establish a session. So this is that's pretty much how it works. WebRTC supports streaming video and audio, and it also supports something called data channels, which is the ability to send messages, usually JSON, a lot in the same way that WebSockets work. I can send a JSON message directly to another peer, and they can send it back to me, so you can build things like chat applications or this game. But that's just one-to-one. So let's talk about multi-peer WebRTC, which is really what we want, because we have a lot of different people, and we want them all to connect to the computer and be able to communicate in a group. There are a few different approaches to doing multi-peer, peer-to-peer communication, in this case WebRTC. The first one is called a mesh, where everyone is connected to everyone. It's very easy when you have a triangle, but when you have more than 3 participants, this becomes very complicated. It means that every machine has to support N connections to everybody else. It's doable, but if we have the game now, I think was about 15 phones connected, it means you have to have 15 sockets open to these machines, and it doesn't really scale very well for mobile phones over local networks or Wi-Fi networks. The other solution is a router. A router is basically a relay. Whatever you send to it, it will send to everybody else. So it's not touching the data. It's completely transparent, and you get all of the events that are emitted for all of the devices. The third solution is a mixer. And what a mixer does is it gets the event or multiple events, it mixes them together, or it does some kind of manipulation, and it sends to each of the devices, it sends a processed event back. So you don't need to get the entire feed and have a lot of processing or manipulation of the data on each one of the devices. You basically pack all the information to what the desired result is, sort of like an API endpoint, and you get it back. This is what we want to use. In our example, the computer does the mixing, and your phones won't have to know about every single event that's fired all the time. Because there's no need. You just need to know when you shot someone or when you died. The computer gets all of the signals from all of the phones, mixes them, and sends the processed output back to the devices. If we look at how communicate, can you read what's on the screen, or is the text too small? I'm going to read it as well. But basically, the way you establish a WebRTC session is that you create, and these are all JavaScript APIs, it's all built in the browser. You ask the browser for your description, and then over a turn server, which would usually be a WebSocket server, you send your description to the interested party. They get your description, generate what's called an answer. They return the answer, which is just their description. And once both sides in the communication have the description of one another, they can establish the peer. They can establish a P2P stream, and the server is no longer necessary. So just like the WebSocket, we ask the questions like, why do we need the turn server? There has to be a better way to do this. And this is what I wanted to do. Basically, serverless WebRTC. We talked about a lot over the last few days about offline applications in Electron and app cache, more negative context, but also service workers. So I'm here to give you some helpful consumer advice about actually doing serverless communication between browsers. So let's look at offline transfer. Like, how do we transfer this SDP, this description? Because this is the problem we're trying to solve. Once we have both computers having this description, it's really easy to establish the session. But this is the bridge we have to cross. So the SDP description is just a relatively small JSON blob. And this is our payload. It's nothing, very complicated. It's not a binary. It's just a bit of text. And it is the crucial step for establishing a peer connection. It's the only step that's actually networked. So what can we do? We can use text input. I can just, call someone over the phone and read them the JSON, just like we were trying to read, the hash for the web torrents between our different screens. And you get that wrong even when I'm staring at the screen and trying to type it into my keyboard. So text input is not a really good way to go. We can use QR codes, but they're out of fashion. And also, it's a lot of text, and scanning them on your phone doesn't always work, and implementing QR codes in JavaScript is a pain in the ass, so no QR codes. We can use Sonar if we want. Like, we can encode the message as some inaudible tone and try to figure out on our phones. We can guess. We can entangle both our computers, quantum entanglement, and hope that we're able to, somehow transmit the SDP. Or we can use Bluetooth, which is what we're going to do. So WebRTC without a turn server over web Bluetooth. That's what we're going to do. So now we're going to talk about web Bluetooth. Has anyone played around or is familiar with web Bluetooth at all? Cool, 2 people. I'm glad. It means I'm talking about something new. That's awesome. So why web Bluetooth? What is it? Web Bluetooth is a web API for browsers, like in your browser, to be able to communicate with Bluetooth 4.0 or Bluetooth low energy peripherals and get data, send data, get notifications, all that cool stuff. Yeah, so it allows browsers to do that communication. It's an API within within Chrome, within Firefox, whatever. You can call it. You can use it right now in Chrome. If you toggle the Bluetooth flag, it's still experimental, but it's there. And it will enable us to send the STP between two different machines without the need for a server. Now, I want to stress the second point, because this is really cool. It means that browsers can communicate, not directly, we'll get to that, but there is a way to communicate between computers without having a signature. Two browsers can indirectly detect one another and create an ad hoc channel of communication. So the communication between Web Bluetooth and WebRTC and being able to establish those connections, at least to me, that's huge, because it means that we're able to create completely ad hoc interaction between devices. Granted, it means that you have to be like within Bluetooth distance from one another, but it's still possible. The catch, and this is the meat of this talk, is that Web Bluetooth works with Bluetooth peripherals. It's not in the same way that you connect between devices and you can share a file. It connects to a peripheral, which is a device that adheres to the Bluetooth Low Energy Protocol. We'll talk about that, and it means that two browsers can't communicate directly into one another. We need something else in the middle to facilitate that. So you can connect to your Apple Watch, or to your Fitbit, or to your connected fridge, or connected toothbrush, as I've seen, but you can't connect directly to someone else's phone. There is a Bluetooth toothbrush, and it will score your brushing, and I don't know if it's necessary. Anyway, what is a Bluetooth low energy, peripheral? How does it even work? What is the protocol that we have to abide by to be able to transfer data? Basically, peripherals are devices that implement the Bluetooth GATT protocol, which is a global, generic attribute model, meaning that they expose a device. This device exposes a service, a Bluetooth service with a particular type, out of typically a list of predefined types for Bluetooth communication, things like heartbeat rate, or a scale, or notifications, or your battery level, or device information. There's a list of supported services. Each service exposes one or more characteristics, and these are the values. And each characteristic in a device can be read, written, and notified, so you can subscribe to updates on that value. And what we want to do is find a way of exposing that Bluetooth service from our machine, so we don't need another piece of hardware or another piece of kit. So expose that Bluetooth service from our machine, so our phones can connect to that Bluetooth service and communicate with the machine directly. So I was looking around when I was starting to work on this, and really there are two sort of feasible ways of doing that at this time. First is Electron. As was mentioned before, Electron mixes Node and the browser, sort of JavaScript engine. So you get extra functionality, and Node happens to have really good Bluetooth libraries, so you can actually export a peripheral. You can turn your machine, your desk, your computer into a Bluetooth sort of beacon or a Bluetooth low energy peripheral from Electron, or you can use some kind of tiny Raspberry Pi that you can carry in your pocket, and it's sort of a cool device that allows computers to connect to one another. That's also awesome. I didn't go that path because I wanted to try and keep things to JavaScript only, so I did it in Electron. We're going with Electron. So the Bluetooth service for WebRTC, what do we have to do? We have to, as I mentioned, we have to define a service that will expose these characteristics, that will allow us to send the offer and the answer across. So that's two characteristics. We need to accept rights of, what it means basically is that a service from the computer needs to offer us their offer, it needs to accept our answers, and it needs to notify us when we're done. And I want to show you a bit of code of what that actually looks like. Oh, yes. Hopefully that'll be readable. I'll just zoom it in really far if it's not. So, what a Bluetooth service basically looks like, and tell me when that's sort of big enough in the back. One more? Yeah? Okay, cool. So I'm using a library called Bleno, Bluetooth Low Energy something, because the opposite is Noble. I guess it's Node. It's just now hit me. And what it looks like is, I'll go from here, is basically the API allows you to define characteristics. So we define one for the offer and one for the answer. We mix these two characteristics into a service, and that service is being advertised. Once it's advertised, if you go on your Bluetooth menus on your phone, not yet, but when I do advertise it, you'll be able to actually see whatever I call the device. In this case, I'm calling it Overboard. You'll be able to see Overboard on your phone as a Bluetooth device coming from Electron, and you can communicate with it with that protocol. So this is the node side of things. This is how I send the data. The web Bluetooth side of things is, what is that? Who's trying to? Come on. Someone's still shooting. That's really cool. Yeah. So on the web Bluetooth kind of thing, the API is really nice. It's on the navigator. In Chrome, you're going to have to go to like Chrome flags and enable web Bluetooth. And what you get is you get the Bluetooth manager on your navigator, in the same way you get user location or device orientation. And what you have to do is you have to connect to a device once you filter for it. So you can see I'm filtering for a device named Overboard, and for a particular service. In this case, I'm piggybacking the automation I/O service. It doesn't really mean anything except for the fact that Web Bluetooth really only accepts if you use one of the predefined services. So you can choose like the fridge data. There isn't a fridge service, but like the heartbeat service with device data, whatever it is. You just need to get one of the services to piggyback to be able to submit your characteristics. So I'm getting the device. It's all promise-based, so it's really easy to interact with. I'm getting the device. I'm connected to it. Then I'm grabbing a service. After I'm grabbing a service, I'm getting all the characteristics, and I'm able to very easily, read and write values. That's all there is to it. And when you read a value, you get a callback with the value. When you write a value, you get a callback saying it worked. If you subscribe to notification, you will get a notification once a value actually updated on my computer. And what that means is that you're able to establish the full cycle of data coming in both ways. Because if I'm writing, so let's say I have a computer and I have a phone. I get an offer. Once I'm connected to the Bluetooth, I can read that offer, but I need to notify the computer that the answer is ready. So I'm able to write the answer, and I'm able to receive a notification for when the browser is ready to create the WebRTC session by subscribing to a notification on that characteristic. And once that is done, once we traded both of our session descriptions, we're able to initialize a WebRTC session. What that looks like is if we go back to the presentation, what that ends up looking like is the entire flow of creating things between, creating a session between WebRTC and Bluetooth. So we advertise our Bluetooth service, we create our, I'll just take this one here. We advertise our Bluetooth service, we create the offer on the client, on the phones, we set our local description, we do all of the flow of requesting the device, connecting the device, getting to the end characteristic, and we write the value back. That's when the computer itself gets a new offer. That's called an offer. It generates an answer from that offer and sets it back to the answer characteristic. A notification is pinged on the device telling it, hey, I'm ready. You can read the value now. We read the value, set the remote description, what's called, and once we have both the local and the remote on the two devices, the session is open, the data channels are open, and we're ready to play. What I want to show you, and I'm going to try and do it with the, what is the app called on Mac so that you can take a photo of yourself? Photo booth? Yeah. Okay, so let's go to the photo booth so I can show you that on my phone. Because, as I mentioned, there's a lot of flags to toggle right now to get this to work on both ends, so you probably won't be able to connect yourself. but you can see me connect, which is almost as good.
So many of you.
And I just want to show you what the interface looks like for getting connected to a Bluetooth device and also proving that it works. So, what is going on? Click photobooth to resume. Okay, cool. So you can see like the alien face barely, and when I click on it, I get asked for a Bluetooth. So you basically get this small window open on top of Chrome, and it will ask for your Bluetooth devices. And once you connect, I don't know if you can see. You see like the entry at the top here? You can't really say that it says Overboard. Maybe you can.
Right on your Mac screen.
Yeah. What?
Right on the Mac screen as a projection.
What do you mean?
Right on the Mac screen.
Oh. My phone? Yeah, that'll work. Thank you. That's much better. Okay, so you can see it says Overboard. It found my device as part of the Bluetooth devices, and the browser prompts you for a connection automatically. So it saw that I have the right kind of service, the right kind of name. It automatically filters the devices, and it prompts me to connect. Once I connect to the device, I can say pair, and now I'm in the game, and I don't know if you can, yeah, and I can shoot myself. So that means WebRTC established between my phone and the computer. There's no server involved, and you can have completely ad hoc peer-to-peer communication. So, hooray! So yeah, this is how it's done. It was really cool to do. The only problem is really that it's really convoluted because you have to create the device on one end, you have to connect the device on another end. WebRTC on its own, if it's not wrapped as a library or something, is also kind of a pain in the ass to set up because you have to send descriptions, get descriptions, track them like in both states. So what I'd really like to do as a next step for this thing is to try and wrap it as a library for you or everybody or me and other projects. Basically plug this in Electron and plug this on the browser and be sort of a wrapper for peer-to-peer communication that's serverless, and all you have to do is sort of trigger it or connect. And you wouldn't have to go through all of this because it could expose, if you expose a common interface in terms of the service ID and the service name, devices can find each other without the need for hassle. Because as you saw before, there's a lot of boilerplate for defining a characteristic and another one, and the service, and advertising, and looking for it, and writing values and reading values. So yeah, setting this up as a library, that's the first thing. The second thing is figuring out another way of trading STP descriptions, maybe over some kind of messaging API, or I don't know, if you have ideas, I'd love to talk about it, to be able to establish WebRTC connections when we're not in Bluetooth range, but still without a server. Maybe like Facebook Messenger API or Web SMS, which is a thing. So if you have any ideas, I'd love to talk about it. The third thing that I mentioned at the beginning, if you remember, I mentioned that all of the game state in this game is managed on one worker, and all the main thread does is rendering. It's basically functions that know how to consume the JSON passed as a buffer from the worker and render the game. What I really want to be able to do is create sort of a distributed gaming framework built on top of the Raft consensus implementation. To be able to manage game state across multiple computers. In this case, there's only one console, so there's only one brain. If we're playing a game like any other game where you have multiple players playing on their computer, it's going to be very difficult to manage game state. So I want to be able to build something, sort of a consensus-based platform, so we can build distributed games over WebRTC, again, without the need for a game server. And that is all I have.
Pretty close. So you probably got a couple of questions, and then Chamo wants to just give us an update on tomorrow. But does anyone have a question? Like, it's pretty cool stuff. Oh, look, Mr. Security.
I'm not even going to talk about security.
Yeah.
I was going to ask you about, you mentioned very quickly random STP generation. It's like you're trying to guess. Have you tried that over the LAN?
No, like I also didn't try quantum entanglement. It was more of a, I don't know.
Because
Maybe.
I'm actually seriously interested to see if that.
Yeah, I mean, that could be cool. You might connect to some random peer somewhere.
I meant more over LANs, right? Because there's only X many people in the room.
That's true, that's true. I mean, in a local environment, that would be easy because everyone has, I guess there's a range of DHCP, so, but as far as I understand, I don't understand fully what is in the SDP description. I think there is also a timestamp, and that makes it harder to guess. I think that's also for that reason.